Hey guys, welcome to a new episode of the Kubernetes tutorial series. As I mentioned in the previous video, we're going to stop a bit on the Kubernetes theory side of things before we can continue with the path to DevOps journey. And today we're going to talk about persistent storage in Kubernetes. And if this sounds fun, let's jump straight into it. Okay, first pit stop, volumes. We need to discuss a bit about volumes in Kubernetes. Now, volumes is a broad term in Kubernetes because it has two big undercategories, let's call them. The first one is ephemeral volumes, which you can see on the screen, and the second one is persistent volumes, which you can also see on the screen, but a bit lower. Now, the thing with ephemeral volumes is that they have the same life cycle as the pod/container. So basically, if the pod gets killed, you lose the volume and the data inside of it. However, persistent volumes, and this is where we're going to have our attention focused today, exist beyond the lifetime of a pod. Let me show you. Let's say you have a pod and the container inside of it, and you mount a volume, which is a persistent volume. Well, container is going to write data into that volume, but if your pod dies, your volume will still exist with all that data inside of it. So you can just create a new pod with a new container and attach that volume, and you will continue where you left off, basically. Two important things to focus on when we talk about persistent storage in Kubernetes is the first one, you would want to access the volume from any node in the cluster, not just in a specific node. So it's not like you can mount that volume directly on the node because that would be node dependent. You need to be smarter with this. And the second part is preferably you would want your storage, your persistent storage, to survive even cluster-wide failures. So somehow you would want this storage to be or to live outside of Kubernetes, right? And I'm saying this because this is like a sneak peek in what's going to follow regarding how persistent storage is designed in Kubernetes. Okay, moving on to PV, which stands for persistent volume, and PVC, which stands for persistent volume claim. Let's talk about an initial way in which persistent storage was designed for Kubernetes. Okay, so as you can see on the screen, the persistent volume is basically a resource in your Kubernetes cluster. Yeah, it's something like, let's say, a pod or a node, or it's like an API resource. That's what I'm trying to say here. Okay, and the persistent volume claim is just a request for storage. Hey, I would like 10 gigabyte of read-only storage, if that's possible. Okay, and the way these two resources work is best emphasized by going through the life cycle. So the life cycle of PV and PVC goes as follows. First of all, you have the provisioning of the persistent volume, which can be two ways, either static or dynamic. Static, it means that a Kubernetes administrator creates that persistent volume for you. Yeah, it runs the command kubectl create PV and gives a YAML manifest where it specifies a lot of attributes of the persistent volume. Or dynamic, you as the Kubernetes developer have the capacity of asking certain storage space from the Kubernetes API, and we'll see that a bit later. Yeah, but basically the first step of a lifecycle for using persistent storage in Kubernetes is the provisioning. Yourself or someone has to provision this storage for you. Okay, then you have the binding. So here's where the PVC, the persistent volume claim, you claim storage. Yeah, you create this Kubernetes object, obviously, it's also a Kubernetes object, and you request certain storage capabilities with it, okay? And then Kubernetes will match a persistent volume that matches the request of your claim. And once a persistent volume matches your claim, it will be bound to your pod, okay? So basically the pod uses the PVC to request a persistent volume. That's how it operates. And then you also have the part of reclaiming, where you have the life cycle you have to think about. You can retain the volume after the pod dies, you can recycle it, so you just delete the data inside the volume, but you keep the volume. And you also have the possibility to delete the volume, you no longer need it, and it just gets cut down. Because I'm certain that a lot of theory without any practice doesn't stick, let's jump straight into the demo, and I hope it will make much more sense after this. But first, I want to tell you that if you want to follow along, you will have all these manifests in my GitHub account, which will be linked down in the description of this video. Okay, without further ado, let's jump straight in. And I hope that you can see the pv.yaml. Yeah, this is the persistent volume that I want to create. And as you can see, like any other Kubernetes object, it has the 4 main fields: API version v1, kind persistent volume, metadata name foo minus pv, and in the spec, we're not using a storage class. We'll talk about storage classes a bit later. Just pause this for a second. And yeah, we will claim it with a persistent volume claim called foo pvc in the namespace default. Capacity 1 gigabyte. The volume mode will be file system. The reclaim policy will be recycle, which means when we lose the pod, the volume will be kept, but the data inside of it will be deleted, yeah, and reset. Access mode, read write once, and local path / bin. So basically, because this is a file system volume mode, we're mounting the file system of the node as a volume, yeah, and more specifically the bin directory of our node. And then we have some node affinity. We're basically requesting only nodes that have Linux operating systems. Okay, nothing too complex. Download the code, analyze it, you'll figure out what it means. But for the time being, let's just copy the path and cd here, and let's do kubectl apply -f pv.yaml, and there we go, persistent volume foo pv got created. So let's do kubectl get pv, and you should be able to see, allow me to minimize this a bit. Okay, looks better now. Yeah, so foo pv, capacity 1 gigabyte, just as we requested it. Access mode, read write once. Reclaim policy recycle, status available, and it should be claimed by a persistent volume claim called foo minus pvc. All right, so let's do just that. Let's create the persistent volume claim. Okay, so this is the persistent volume claim that's going to claim our volume. Again, API version, kind metadata spec. It says which volume it wants to claim, the access mode which needs to match, and it only requests 256 megs of storage, not 1 gig. Okay, so let's do kubectl apply -f pvc.yaml, and there we go. Now if we do kubectl get pvc, you will see that it is bound, yeah, and if we do kubectl get pv, you will see that it is also bound. So we created the persistent volume claim and we claimed the volume. Okay, and now we should deploy the pod to use the persistent volume claim. As you can see here, as a volume, we will mount the persistent volume claim. Yeah, this is very important. You don't actually mount the volume, you mount the claim. So kubectl apply -f, and let's do pvc underscore used by pod. And now if we do kubectl get pod, you will see that we're now creating one container and now it's running. Okay, so let's spend some more time here. Kubectl describe pod. Yeah, as you can see here, when you describe the pod, you will see in my pod the volume of type persistent volume claim, which is a reference to a persistent volume claim in the same namespace, and it also tells you the name of the claim. Yeah, so from the pod you can go to the claim, and from the claim you can actually go to the volume. All right, and if we look at the mount point, it's /host folder. So let's do a kubectl get pod. Okay, and kubectl exec, let's enter the pod. There we go. And as you can see, we have a folder called host folder. So if we list what's inside of it, you will see that we actually have the binaries from our node. All right, so all of these binaries that you can see here are actually binaries from the host node. Yeah, we took the bin folder from the node, we created a persistent volume from it, and we mounted that volume inside of our container on the /host folder. Yeah, that's where we mounted it. So basically we now have access to read from the binary of the node through our container using persistent volumes and persistent volume claims. I hope this clears out how persistent volumes and persistent volume claims can be used, but obviously there are a lot more types of persistent volumes than you can use. Yeah, I just used a persistent volume of type file system. Yeah, but you can use actual cloud storage, you can use cloud disks, cloud file shares to mount them as persistent volumes. This one was just for the simplicity of the example. And now on to the self-service side of persistent storage in Kubernetes, which are storage classes. And you can read the definition on the slide yourself, but as an administrator, you can leverage storage classes to give developers, Kubernetes developers, certain interfaces to self-serve from different types of storage. And allow me to show you. Yeah, this is a storage class, or basically a snippet, a small snippet of a storage class in YAML. And basically, as you can see, you will use the Azure Disk Provisioner. So this one will be a cloud-based persistent storage, and you teach Kubernetes to rely on the Azure provider for Kubernetes disks, the Azure storage provider, in order to allow developers to self-service from those Azure disks with obvious restrictions to how much size they can use and all the other configurable parameters. But basically the storage class allows the AKS cluster to self-service from the Azure storage provider. So when you create a persistent volume claim and you ask for a disk of 10 gigabytes, it will create a persistent volume for you, but that persistent volume will actually be backed by an Azure disk. And that's the beauty of it. Yeah, you can allow your developers to self-service on demand from Azure storage without actually knowing the intricacies of Azure storage or any cloud provider storage. Yeah, we're talking about Azure because that's what I know best, but you can integrate it with AWS S3, you can integrate it with GCP storage. Without further ado, let's jump straight into the demo because this is best understood once we look at it. Okay, jumping straight into the demo, we can look at the storage class object that we're going to provision in our cluster. And as you can see, API version, kind, metadata, we gave it a name, but then we have other fields. For example, provisioner. In our case, it's going to be kubernetes.io/Azure Disk. So we're going to back our storage class with Azure Disks. And as parameters, we only allow storage account types of SKU standard LRS, and kind will be managed. Reclaim policy will be delete. So when we finish using each of those volumes, they'll get deleted. We don't want to keep the information inside of them. You can tweak this to make it keep the volume if you want. Allow volume expansion true. So if we want to increase it, it will be possible. And volume binding mode immediate. It means it will immediately bind the volume whenever you create the storage, the persistent volume claim. Okay. So let's deploy the storage class, and this will be done by kubectl apply -f storage class. And there you go, storage class Azure Disk created. Kubectl get storage class in one word. And obviously we have some default ones that got created with the cluster, but there we go. We have Azure Disk, which is 11 seconds old. Yeah, plus some others which came with our default cluster. I'm using an AKS cluster, so you have some default ones. All right, so Azure Disk got created by us 11 seconds ago. Now let's use it. So in order to use this storage class, I'm going to create a persistent volume claim, and I'm going to rely my persistent volume claim on the storage class with the Azure Disk name, which is the storage class we just created. Yeah, and I'm going to say, yeah, I want read write once access mode, and I want 2 gigabytes of data. Okay, so kubectl apply -f storage class PVC, and the PVC got created. You can see it here, and it's also bound, and it's going to be bound with a volume with this name. So if we do kubectl get pv persistent volume, you will see the volume got created for myself automatically. Yeah, so I didn't actually have to create a volume. No one created the volume for me. I just said, hey, storage class, can you give me a volume of 2 gigabytes size? And it gave me that. Yeah, I just didn't choose the name for it. It chose a random PVC minus some GUID name, but I now have it and I can use it as I want. I can mount it in my pod and do whatever I want with it. I actually want to do one more thing for you, so just give me a second. A few moments later. Okay, smooth transition over. So we're now in the Azure portal. I wanted to show you that this is the resource group where the resources from my AKS cluster sit. Okay, and if I zoom in, I want to show you that we have a new resource. Let's scroll down. This one, yeah, this disk, which if we look at the name, 687E FB07, 687E FB07. So this disk got created for us by the storage class. Yeah, we just requested this from the storage class, and it got created in the same resource group as where our Kubernetes resources sit. And as you can see, disk size is 2 gigabytes. Disk SKU is standard LRS, yeah, and it's a hard drive, it's not SSD. And basically it was created a few moments ago, it seems. I'm not sure why it's 0:25:15 p.m., but anyway, I think this means 12 p.m., but 0 is weird. Anyway, this is the disk that we created, okay? So I want to show you one more thing. If we go back here and I want to delete the persistent volume claim, if you remember, the storage class reclaim policy was delete. So when we delete the claim, hopefully the volume will get deleted too. So let's do kubectl get persistent volume, and as you can see, there's no persistent volume left anymore. Kubectl get pvc, there should be no claim left as well. Kubectl get storage class. Now we should still have the storage class, and indeed it's 5 minutes old and it still exists. And if we go back to the portal and I refresh this, resource not found. Yeah, so the volume got deleted as well. The Azure volume, which was backing our persistent volume in Kubernetes, got deleted. Thank you so much for sticking so far throughout the video. If you're still here and you followed along, good for you. If you haven't followed along, I strongly recommend that you do, because doing stuff consolidates knowledge, and you should get your hands dirty in the beginning to understand how things work. There's a lot of available material regarding persistent volumes, persistent volume claims, and storage classes. I hope what I presented today got your interest and you're going to study more. Don't rely on this small tutorial for everything related to persistent storage in Kubernetes, because this is such a vast field and you should do your own research. These are just some examples that can get you started and help you understand the basic concepts like self-servicing, your own persistent volumes using storage classes, for example. Once again, thank you so much for still being here. I hope I haven't bored you to death, and I wish you a great one wherever you are. Cheers. See you next time.